on this problem, we only need to determine the form of a particular solution. So it's only the form. So it's going to have some constant in it. We do not solve the equation. Right. So just take a look at the non-homogeneous equations. The first equation. Notice the right-hand side is going to be e to the 4t. So the particular solution will have to have e to the 4t in it. We will not know the coefficient, so it's just going to put a in front of it. So the particular solution, we're going to have that form. Actually, we need more space, so let's just write that here. Right. Next, we're going to have sine of 9t. But then there's a t in front of it. So every time we have a trig function, I mean sine or cosine of a function, then we're going to have the same. But this time we have a t in front of it. So this which means we have to multiply by the same order of polynomial. So this is t to the first power. So we're going to have the form of, we cannot use a anymore. So let's use something else. We're going to be bt plus c times sine of 9t, and then the cosine of 9t with different linear function in front of it. So c, we will not want to use d, so let's use e, because d usually for derivative, so let's just skip that. So et plus f cosine of 9t, right? And next we have the cosine of 9t. For cosine of 9t, it's just like when we have sine of 9t, we just need to have sine and cosine. Usually we're going to have cosine before sine, so let's just stick with that convention. Right. So for cosine of 9t, we're going to have again cosine of 9t and sine of 9t. But since there's no polynomial in front of it, we just have coefficient. Let's say g of cosine 9t and h. And we just have those two add together. And the solution, all of this, add together. Just note that since we have both of this have cosine of 9t, and we have a constant and a constant. A constant plus a constant is another constant. So that's just pretty much like what we usually do in integral. And this will have sine of 9t, a constant plus another constant is still constant. So when we put all of this together, we're going to have a of e to the 4t plus bt. We can say g, c plus g, but that's still a constant. So we really don't need g because those two are just constant. So we use c, cosine of 9t. Similarly here, we just have at those those sorry, these two constants add up, still a constant. So let's just say, just use f, and then there will be sine of 9t. All right, it's almost done for that problem. One thing we need to focus on is we have to consider the homogeneous solution as well, because there might be some redundant with our solution. All right, so let's just find homogeneous solution. The left hand side, we just have this, which corresponding to the auxiliary equation of r squared minus 14r plus 50 equal to 0. And if we solve for r, this will be complex. R equal to negative 14 plus or minus square root of negative 14 squared minus 4 AC over 2A. If we do that, we should have 7 plus or minus 14 squared is 196 minus 200. So it'll be square root of minus 4 over 2. So 7 plus or minus 2i. I'm sorry, that's 14, not 7. Sorry. I'm thinking ahead and dividing already. Anyway, plus my 2i. Again, that is 14. And that gives us 14. That should be 7 now. 7 and plus or minus I. Notice both 14 and 2, both 14 and 2 divide by 2. So we have 7 plus or minus I. Right. Now we go back to our problem. A to the 4t a to the 4t, the solution is corresponding to the root of r equal to 4. When we have e to the rt, then we have r equal to 4. So that one, the solution corresponding to it is r equal to 4. The t sine of 9t, usually every time we have sine cosine, the solution could be in the form of alpha plus or minus beta I. If that is the root, then the solution is going to be e to alpha t cosine alpha t, and y1 and y2 is e, that beta, sorry, e to the alpha t sine of beta t. So every time we have sine or cosine, the solution is going to be in that form. This form we corresponding to this solution is going to be r equal to, it's going to be 9, so 9 is going to be beta, so it will be plus or minus 9i, and in front of it we can write e to the 0 power if we want to. So this is going to be just 0 plus or minus 9i, or just plus or minus 9i. So that is the solution, the r that gives us sine of 9t. But then we have the t in front of it, so this actually is going to be a double root. This is not important, but to get to a t, we need a double root of that. And for cosine of 9t, it's going to be the same. R is going to be just plus or minus 9i but this time it is a single root. Double root, single root, it doesn't matter. What important is on the left hand side we have 7 plus or minus I, and it is different than this one, different than this one, and different than this one. So the particular solution is going to be just that. Right. Now we'll go to the next part, the next equation. On this one, we're going to have 3t plus 1. So that is a polynomial. So the particular solution, we have the form of a to the, at plus b. So the particular, we have the same form as the polynomial. We only need 3t. The plus 1 here doesn't matter, but the form is always have to have the full polynomial. For example, if we have 3t squared, then the corresponding to that is going to be at squared plus bt plus c. The solution, the guess for the particular solution have to have the full polynomial which have the same degree as the highest one. Right. Since we have 3t plus 1, degree of 3t is 1, so we're going to have at plus b for the form of the solution. Right. Next, we have the t a to the 4t. So for that, we're going to have a to the 4t, the same form of it. And then in front of it, have to have the same polynomial. So it's going to be, we have a, b, let's use c. I really don't want to use d. Let's say e. Right? We just add those two. By the way, let's just say that for the whole term of 3t e to the 4t. Right? So that is kind of the form what we have. But those could change depends on the solution we have on the homogeneous solution. Right? Let's just find a homogeneous solution. Homogeneous solution. On the left hand side, the auxiliary equation corresponding to the homogeneous equation is r cubed minus 4r squared equal to 0. So with that, we can factor out r squared. So we have r equal to 0, and this is a double root, very important. We have to distinguish the single root, double root, or any higher multiplicity. And r equal to 4, and this is a single root, or multiplicity of 1. Right. Now we have the roots for the homogeneous equation, or for the part of the homogeneous solution. Now let's look at what the root we have in this case. For at plus b, the solution of that is equal to 0. Because in general, when we have r equal to something real, then the solution is going to be e to the rt. In this case, we just have e to the 0t, which is 1. So instead of write at plus b, we can also write at plus b times e to the 0t. We can also write like that. E to 0t is just 1. Right, but we don't write e to the 0t. So we just have at plus b then. All right. And then for a polynomial times e to the 4t, the solution to this is going to be 4 and multiplicity of 2 because we have a polynomial of degree 1 in front of it. It's not really important, the multiplicity on this particular solution. We know that r is equal to 4. Right. Now we go back to the homogeneous solution. We see that this we have r to the 0 power. R equal to 0, and it is the double root, meaning that we have the same solution here. The same solution of r equal to 0 appear twice or multiplicity of 2 on the homogeneous solution. So for this, we have to multiply this at plus b by t squared to it because of multiplicity of 2. The solution of r equal to 4 appear once in the homogeneous, in the auxiliary equation. Because it appears once, we're going to need t to the first power. And adding those two is going to be the form of the particular solution. So we say the particular solution is going to have the form of at cubed plus bt squared, and then plus ct squared plus et, and then e to the 4t. That's what we have for this problem.